Hello everyone. So today our topic is autonomic nervous system. In this session we will cover the introductory part of autonomic nervous system. So basically it is a revision of your first year physiology. Whatever you learned in first year physiology about autonomic nervous system, this session will be about briefing of autonomic nervous system. In upcoming lectures, we will learn drugs acting on autonomic nervous system. So this session is about brief revision or introduction of autonomic nervous system. So we all know what is autonomic nervous system. It is part of CNS, and subsequently, autonomic nervous system is peripheral nervous system, part of peripheral nervous system. So as the name suggests, autonomic. So it is a system that acts largely unconsciously and regulates bodily functions. So we all know ANS controls heart, lungs, GIT, various glands, blood vessels, and that control is unconscious. So ANS is a control system that acts largely unconsciously and regulates bodily functions. So what are the central connection of autonomic nervous system? Now autonomic nervous system is governed by central or organs, brain parts like hypothalamus, midbrain, and medulla. All these brain parts control the autonomic functions: hypothalamus, midbrain, medulla. Now, ultimately, we all know autonomic nervous system has two parts. One is sympathetic system and other is parasympathetic system. Now, both are basically opposite of each other. Not always, but basically these both autonomic arms are having opposite actions: sympathetic system and parasympathetic system. Now sympathetic system prepares body for emergency, like fighting, like fight response or flight response. Suppose someone slaps you, you are in a fight, so then your sympathetic system will be stimulated more. Or similarly, suppose a dog is chasing you, you are running away from a dog. So that is a flight response. In both fight or flight response, the sympathetic system is more in work. And exactly opposite of this fight or flight response is rest and digest. When you have suppose a great meal or great lunch and you are relaxed. Now in that case parasympathetic system will be more at work and it will conserve the energy. So rest and digest. So parasympathetic system function is to conserve the energy, and sympathetic system prepares body for the fight or flight response, or we can say adrenaline rush. We can say adrenaline rush. So both systems are having opposite actions, sympathetic system and parasympathetic system. Now we will learn something about sympathetic system, about its origin. Now sympathetic system origins from spinal cord, and spinal nerve dorsolumbar or thoracolumbar. So thoracic nerves T1 to lumbar L2 or L3 nerves. So sympathetic nervous system has dorsolumbar origin from T1 to L2 or L3. Sympathetic system has dorsolumbar or thoracolumbar origin T1 to L2 or L3. Now in sympathetic system, the the nerve ganglia are away from the organ supplied. Suppose an organ is there and the nerve is supplying the organ, but the ganglia is far away from the organ. So post preganglionic fiber and post ganglionic fiber. So in case of sympathetic system, post ganglionic fiber will be long because ganglia are away from the organs. So in case of sympathetic system, post ganglionic fiber are long. Now sympathetic system, we all know in brain or in ANS we need some chemical messenger. In sympathetic system, that chemical messenger or neurotransmitter is noradrenaline. Remember, it's not adrenaline, it is noradrenaline or also known as norepinephrine. In sympathetic system, major neurotransmitter is noradrenaline. So all the signals in sympathetic system is conveyed to that particular organ via neurotransmitter noradrenaline. And this system, function of this system is to prepare for fight or flight. So once again, origin of the sympathetic system is from dorsolumbar T1 to L2 or L3. Now in sympathetic system, the ganglia are away from the organ supplied. So post ganglionic fibers are long. A neurotransmitter in sympathetic system is noradrenaline. Noradrenaline or else known as norepinephrine. And the function of this system is to prepare body for fight or flight response. Supposing you are in fight, so your heart rate will be increasing. That is a fight or flight response. Your heart rate will increase. Now parasympathetic system. So we have seen the sympathetic system. The origin was dorsolumbar. In parasympathetic system, the origin is craniosacral. Craniosacral means cranial nerves will be involved and sacral nerves. So in parasympathetic system, origin is craniosacral. So cranial nerves 3, 7, 9 and 10. Remember, parasympathetic system originates from cranial nerves 3, 7, 9, 10 and sacral nerves S2, S3 and S4. So parasympathetic system origin is from craniosacral. Now unlike sympathetic system, in case of parasympathetic system, ganglia are near to the organs. Ganglia are on or close to the organ supply. So post ganglionic fibers will be short. Ganglia are very close to the organ. So post ganglionic fiber will be short. Now in sympathetic system, transmitter was noradrenaline. Here the major neurotransmitter is acetylcholine. So parasympathetic system is sometimes called cholinergic system. Cholinergic system because the neurotransmitter is acetylcholine and the function is, we already know, rest and digest. So it basically preserves energy. So we have seen sympathetic and parasympathetic system. Origin parasympathetic system origin is from craniosacral. Cranial nerves 3, 7, 9, 10 and sacral nerves S2, S4. In case of sympathetic system, it was thoracolumbar or dorsolumbar. In parasympathetic system, ganglia are close to the organ. So postganglionic fibers are short, opposite to sympathetic system in which ganglia are away from organ. So postganglionic fibers are long. Here the neurotransmitter is acetylcholine. In sympathetic system it is noradrenaline or norepinephrine. Function of parasympathetic system is rest and digest. So sympathetic system basically prepares body for the physical intense activity, fight or flight. And opposite parasympathetic nervous system relaxes the body and conserves energy, rest and digest. Here fight or flight, then rest and digest. So we all know the term adrenaline rush, that is due to stimulation of sympathetic nervous system. Here the neurotransmitter is noradrenaline. Here the neurotransmitter is acetylcholine. Now we know this term, or you might have heard this neurochemical transmission or neurohumoral transmission. We know the neurotransmitter acetylcholine and noradrenaline. So basically what is transmission? Nerve will release the chemical substance. Autonomic nerves will release the chemical substance. That chemical substance will act on the organ. So all this is known as neurohumoral transmission. Nerve will transmit their message across the synapse and neuroeffector junction by the release of chemical messenger. In case of sympathetic system we have noradrenaline. In case of parasympathetic system we have acetylcholine. So this is known as neurochemical or neurohumoral transmission. Nerve will release some chemical substance. It will act on organ. So all this is known as neurohumoral transmission. So first we will see sympathetic system in which transmission is noradrenergic, because neurotransmitter involved is noradrenaline. So this transmission is noradrenergic transmission. So there are basically few steps in transmission. First we have to make noradrenaline. First we have to synthesize noradrenaline. Noradrenaline is synthesized from tyrosine. Noradrenergic transmission. There are basic steps. First step is synthesis of noradrenaline, which is synthesized from tyrosine. Now this noradrenaline is stored. It has to be stored in some place. So in nerve fibers, noradrenaline is stored in vesicles. Vesicles are basically storage house. So vesicles will store noradrenaline. Now upon stimulation or arrival of impulse, there will be release of noradrenaline from nerve ending. There will be release of noradrenaline. Now after the release of noradrenaline, noradrenaline will act on organ supplied, and that organ will have receptors for noradrenaline. Now noradrenaline will act either on alpha or beta receptors. In noradrenergic transmission, the organs have two types of receptor, either alpha or beta. Now noradrenaline will act on alpha or beta receptor. Suppose in heart, noradrenaline will increase the heart rate by acting on beta receptors. In heart there are beta receptors, particularly beta 1 receptors. We will see. So noradrenaline will act on beta receptor, and it will effect of acting on beta 1 receptors will lead to increase in heart rate. So after the action is completed, there has to be termination of action. Now how this termination occurs? This released noradrenaline again will travel back to nerve endings via some molecule known as transporters. So this noradrenaline will again be uptaken in the nerve ending via some molecules known as transporter. So that will be the termination of action. Noradrenaline will be again taken in nerve ending by transporter. Also, noradrenaline after that will be metabolized by two enzymes. Noradrenaline will be destroyed or metabolized by two enzymes known as COMT, catechol O-methyl transferase. Catechol O-methyl transferase, and another enzyme is MAO, monoamine oxidase. Monoamine oxidase. So this is the basic steps. These are the basic steps of noradrenergic transmission. Synthesis from tyrosine. Then this noradrenaline synthesized from tyrosine is stored in vesicles. Now upon arrival of stimulation or impulse, there will be release of noradrenaline. Then noradrenaline will act on the organ by acting on the receptors like alpha or beta. After that action, the termination of action is due to uptake of noradrenaline again in the nerve endings by molecules known as transporters, and that noradrenaline will be metabolized by two enzymes, catechol O-methyl transferase and monoamine oxidase. So this is a general or basic outline of neurohumoral transmission in sympathetic system. This is a sympathetic nerve ending now, and this is the organ. Here example, vascular smooth muscle, smooth muscles, vascular smooth muscle. Now here is the noradrenaline or norepinephrine. On arrival of stimulus, norepinephrine, which is stored in vesicles. These norepinephrine molecules are stored in vesicles. Upon arrival of stimulation, these norepinephrine molecules will be released. These noradrenaline molecules will act on the receptors, either alpha or beta receptors, and accordingly there will be action on vascular smooth muscle like constriction, vasoconstriction. Vascular smooth muscle will contract or dilate, vasodilation or constriction. And after the action, after that the termination of action will be this noradrenaline after acting again will be taken up by the nerve ending, uptake. After acting on the receptor, noradrenaline will again travel back to nerve ending by some molecules known as transporter, and norepinephrine can be metabolized by two enzymes, COMT and MAO. So this is basically neuroeffector or neurohumoral transmission. This is neurohumoral neurochemical transmission. So basically simple, norepinephrine is synthesized from tyrosine, stored in vesicle, released on arrival of stimulation. After that noradrenaline will act on receptors and termination will be due to uptake inside the nerve ending by transporter. Also they are metabolized by two enzymes, COMT and MAO. So this is basically sympathetic transmission or noradrenergic transmission. Now in sympathetic system we have talked about receptors. There are basically two types of receptors, alpha receptors and beta receptors. Alpha receptors are of two types, alpha 1 and alpha 2. Alpha receptor has two subtypes, alpha 1 and alpha 2. Beta receptors are of three subtypes, beta 1, beta 2, beta 3. Alpha 1, alpha 2, beta 1, beta 2, beta 3. So this is the overview of sympathetic transmission. Neurotransmitter involved is norepinephrine, noradrenaline or norepinephrine. Receptors are of two types, alpha and beta. Alpha 1, alpha divided into two parts, alpha 1 and alpha 2, beta three subtypes: beta 1, beta 2, beta 3. Now we will see overview of cholinergic or parasympathetic system transmission. Here the neurochemical involved is acetylcholine. So this is known as cholinergic transmission. So in cholinergic transmission, for similar like to sympathetic system, we have to synthesize. We have to synthesize acetylcholine. So synthesis of acetylcholine is from acetate and choline with involvement of enzyme. There will be synthesis of acetylcholine. Now again acetylcholine will be stored in vesicle. Similarly in sympathetic system noradrenaline was there and it was stored in vesicle. Now again arrival of stimulus, there will be release of acetylcholine from nerve endings. Now acetylcholine similar again will act on organ which have receptors. There will be action on receptor and there will be some activity on the organ. Like suppose salivary gland is there. Cholinergic transmission, acetylcholine will act on the some cholinergic receptor and there will be salivation, increase in secretion of salivary gland. So that is the post junctional activity. Now to terminate that activity there will be rapid action by choline esterase enzyme. The termination of action is due to activity of choline esterase enzyme which rapidly destroys acetylcholine. In case of sympathetic system there was uptake of noradrenaline. Here there is destruction of acetylcholine by choline esterase enzyme. Choline esterase enzyme. So basic steps are similar. First we have to synthesize acetylcholine. There is storage of acetylcholine, release of acetylcholine, action on some receptor. There will be some post-junctional activity and ultimately destruction of acetylcholine by choline esterase enzyme. So in sympathetic system there were two types of enzyme, alpha 1 and alpha 2. Here there are two types of receptors. Parasympathetic receptors system has two type of receptors. Muscarinic M1, M2, M3, M4, M5. But for practical purpose we should remember these three: M1, M2, M3. M1, M2, M3. And another group is nicotinic receptors which have got two, an M receptor and an N receptor. So muscarinic and nicotinic type of receptors. In sympathetic system there were two types, alpha and beta. Here muscarinic and nicotinic. Muscarinic has got 5 receptor subtypes, M1 to M5. But for practical purpose we will focus on M1, M2, M3. And nicotinic are of two types, NM and NN. So this was the overview of parasympathetic system. So now example, M2 receptors. In parasympathetic system, M2 receptors are on heart. When acetylcholine acts on M2 receptor, there will be decrease in heart rate. There will be decrease in heart rate. Now opposite to that of sympathetic system, beta 1 receptors are in heart. Remember, beta 1 receptors are in heart. And when noradrenaline will act on beta 1 receptor, there will be increase in heart rate. So both action are opposite. When acetylcholine acts on M2 receptor, heart rate will be reduced. When noradrenaline acts on beta 1 receptor, heart rate will increase. So this is the opposite action. So this is the overview, sympathetic nervous system, will prepare body for the emergency response, fight or flight. And parasympathetic nervous system will relax the body and will conserve the energy, rest and digest. So both have opposite action. Now another part of the central nervous system or ANS or subpart we can say is enteric nervous system. In GIT there is a separate entity, separate nerve plexus is there known as enteric nerve system, which involves both sympathetic system and parasympathetic. Plus it has got its own reflexes. So it is entirely a separate nervous system, which, which is termed as enteric nervous system. Enteric nervous system. So in GIT there is plexus of nerves which involves both sympathetic supplied by both sympathetic nervous system and parasympathetic system. Plus it has got its own reflexes. Ultimately this enteric nervous system will control the GIT movement, peristalsis plus secretion in GIT. So it is known as enteric nervous system. The enteric plexus of nerves receives input from both sympathetic and parasympathetic. Plus it additionally it functions independently. It has got its own reflexes. And the whole function of enteric nervous system is to regulate the bowel movement, GIT secretion and absorption. So this is known as enteric nervous system or otherwise known as gut brain. Gut brain. So this system controls the GIT, enteric nervous system. It receives input from both sympathetic nervous system and parasympathetic nerve. Plus it has got its own reflexes. And ultimate function of this system is to control the GIT motility, secretion and absorption. So this is enteric nervous system. So this was all about introductory part of ANS. So we have seen two things: sympathetic nervous system, flight or fight response; parasympathetic nervous system, rest and digest. We saw the neurochemical or neurohumoral transmission, which are basically common step. First, we have to synthesize the neurotransmitter. In case of sympathetic system, there is noradrenaline, synthesized from tyrosine. Neurotransmitters are stored in vesicles. Upon arrival of impulse, these neurotransmitters are released. After they will act on receptor, there will be some action on the organ and there will be termination of action. In case of sympathetic system, noradrenaline will be again travel to the nerve ending by a transporter. So that is the termination of action. In case of parasympathetic system, acetylcholine will be destroyed by cholinesterase enzyme. We learned the receptors. In sympathetic system, there are two types of receptor, alpha and beta. In parasympathetic system, again two types, muscarinic and nicotinic. And in that, there are also subtypes, alpha 1 and alpha 2 for sympathetic system and beta 1, beta 2, beta 3 for sympathetic system, alpha and beta. Parasympathetic system, muscarinic and nicotinic. Muscarinic M1 to M5, nicotinic NM and NN. And we saw the enteric nervous system, basically gut brain, which controls the movement, GIT movement and secretion and absorption. So that is enteric nervous system. So this was all about introduction or revision part of ANS. In future lectures, we will learn the drugs acting on parasympathetic system and sympathetic system. So this was all about introductory part of ANS. Thank you.